right, well, we're going to talk about how to find the equation of a function given a graph. I have two different examples right here, and this is specifically talking about with the cosine graph. When you have a cosine graph, we know that cosine always begins with a normal cosine graph always begins at the origin at 1, okay? And then it goes by pi over 2, all right, then pi, and so on and so forth. And so when we have this, it goes down over here, and then we go to 3 pi over 2, and then 2 pi is our last value. And what you notice is that when you have this, all right, we're looking for that one whole period. So when we are asked to find a cosine graph, the first thing is we have to identify is what's the line of oscillation, which really starts at y equaling 0, okay? And what's our amplitude, and then if it's been shifted. Well, in this particular equation, it's saying we're only asked to find A and D. D is basically what's the vertical shift, and actually that will help us determine what is our line of oscillation. Okay, so actually D equals the midline. I'm using much different terms here, or what we also call the line of oscillation. That's what makes it go up and down. And so if we look at these different graphs, how do we determine this line of oscillation? Well, we determine the line of oscillation by taking the max and the min and finding the middle of it, because that is what we refer to as the midline. And so in this particular example, we have 1, 2, 3. So we have a 3, and then we have a -1. Well, 3 plus -1, all right, and then we divide that by 2. That will give us our midline. And our midline, also known as the line of oscillation, all right, is actually equal to D. And so what we notice what we have here is going to equal 1. And so if we go right there, we can see that D is going to equal 1 in this case. All right. All right. And what we notice then is that we can also note that our amplitude, because the amplitude is our A value, is going from the line of oscillation to the top, line of oscillation to the bottom, and you realize that is 1, 2, and 1 and 2. So our amplitude is going to equal 2. And so for this equation, it's pretty easy to see. Since we are starting right here at the max, all right, we're going to have f of x is going to equal 2 cosine of x plus our line of oscillation, our vertical shift, and moving that line up 1. And that is our function for this graph. Doing the same thing over here, we notice that we have cosine, but if you notice right there, cosine is now going below, and we know that it always begins usually going up. And so what that means is that we have a reflection. So if it's going the opposite way, we have a reflection. So our A value is going to be negative. But before we do that, let's find our line of oscillation, and so let's find our midline. So if we take our top, which is 8, and we take our bottom, which is 0, and we find our midline, our line of oscillation, that's going to equal 8 plus 0 divided by 2, and our midline actually is equal to the D value, our vertical shift. And so we realize that can equal 4. And you probably could eyeball that as well. So that is where this line of oscillation is going. And so to figure out our next values, what is our amplitude? Well, we realize the amplitude goes from the midline or line of oscillation to the top, or midline to the bottom, and we realize that's going to be 4, all right, and our amplitude is 4. Now, because this is reflected, all right, instead of going up, is going down here at the origin, we know that our A value is going to be negative. That is a reflection, all right, reflection, all right, over the, well, this would be over the x-axis, okay, but it's a reflection. And then we're going to take A, which we know is 4. We're going to take cosine of x. We're going to add in our line of oscillation where we've been shifted to, and that's going to equal 4. And so there, my friends, is our equation for this cosine graph. So once again, when you're going through these, the key thing is understand what cosine looks like at their origin at 0, and it starts at what, 0, 1. So you're looking at that. Find our line of oscillation, or midline, which is usually at 0, but it's been shifted up or down. That's our D value. Our A value, once we have that, is our amplitude. Okay, help us find our amplitude, distance from the midline or line of oscillation to the max, or midline to the min. Find that, that's your A. Determine if it's going to be reflected. That tells you if you're going to have a negative or not. Hope that helps you out, and good luck in Galvus and some other problems.